In this lecture, we discuss more important based on the reduction formula. The question is, if in is equal to integration of sine to the power 2nx and under the limit 0 to pi by 4 with respect to x, prove that in is equal to 1 minus 1 upon 2n times of in minus 1 minus 1 upon n into 2 to the power n plus 1. Hence, evaluate I2. How to solve these questions? We have given that in is equal to integration of sine to the power 2nx dx under the limit 0 to pi by 4. We will first find the reduction formula of sine to the power 2nx dx. For this purpose, we break sine to the power 2n into two parts, sine to the power 2n minus 1x and sine x. Under the limit should be same. Now we apply the integration by part. This sine to the power 2n minus 1x is the first function, or we can say that u, and this is v. So if we apply the integration by part, what is integration by part? uv dx, which is equal to u integration of v dx minus derivative of u with respect to x integration of v dx and whole integration. Now here u is equal to sine to the power 2n minus 1x into integration of sine x. Integration of sine x is minus cos x. If we substitute the limit under the limit 0 to pi by 4 minus integration under the limit 0 to pi by 4, we have to find the derivative of u. So u is equal to sine to the power 2n minus 1x. Derivative of x to the power n is n, x to the power n minus 1x. Again, derivative of sine x is cos x, and integration of sine x is minus cos x dx. If we again simplify it, if we put the limit over here, sine upper limit is pi by 4, sine to the power 2n minus 1, x is replaced by pi by 4, and there is a minus sign we have taken outside, cos pi by 4, and if we put the lower limit, then this will be 0, sine 0 is 0, cos 0 is 1, so 0 into 1 is 0, plus this minus, and this minus will become plus 2n minus 1 we are taking outside, sine to the power 2n minus 2x, cos x into cos x is cos square x. We know that what is the value of sine pi by 4 or cos pi by 4? It is 1 upon root 2. 1 upon root 2 whole to the power 2n minus 1 multiply by value of cosine is also cos pi by 4 is 1 upon root 2 plus 2n minus 1 sine to the power 2n minus x into cos square x can be replaced by 1 minus sine square x, because sine square theta plus cos square theta is equal to 1. Let us go ahead. In is equal to 1 by root 2 whole to the power 2n minus 1 plus 1 plus 2n minus 1 integration under the limit 0 to pi by 4 sine to the power 2n minus 2x dx minus 2n minus 1 under the limit 0 to pi by 4 of sine to the power 2n minus 2 plus 2, because it was 1 minus sine square x. It should be multiplied with sine to the power 2n minus 2x dx. So if you multiply with 1, we are getting the same expression. And if you are multiplying with sine square x, this plus 2 will be added over here. Now this is 1 upon root 2 whole to the power, this minus 1 plus 1 will cancel, whole to the power 2n plus 2n minus 1, 0 to pi by 4, sine to the power 2 times of n minus 1 x dx minus 2n minus 1 integration under the limit 0 to pi by 4 sine to the power 2n dx. This can be written as, if we remove the root sign, then 2n upon 2 minus 1 by 2 whole to the power 2n by 2 plus 2n minus 1. This is nothing but in minus 1, because in the integration, what is integration? We have given in is equal to 0 to pi by 4 sine to the power 2nx dx. So in place of 2, n, it is n minus 1. So we can write down it is in minus 1. And here, this is in. Therefore, this will be replaced by minus 2n minus 1 into in. This term should be replaced to the left-hand side. It will become in, and this is, since it is minus, so if it will come to the left-hand side, it will become plus 2n minus 1 in, which is equal to minus 1 upon 2 whole to the power n. This 2 will cancel. 2n minus 1 into in minus 1. Again, this is in plus, and this in negative will cancel. This will cancel. We have in, and now if we simplify it, minus 1 upon 2 to the power n plus 2n minus 1 in minus 1. This 1 and 1 will cancel. It will convert it to, it will reduce 2n into in, which is equal to minus 1 upon 2 to the power n, 2n minus 1 into in minus 1. Let us divide whole equation by 2n. Then in is equal to minus 1 upon 2n into 2 to the power n plus 2n minus 1 upon 2n into in minus 1. Again, 2n means 2 into 2 to the power n, which will become 2 to the power n plus 1, plus 2n upon 2n minus 1 upon 2n. So this will again cancel. We have in is equal to minus 1 upon n into 2 to the power n plus 1 plus 1 minus 1 upon 2n times of in minus 1. This is our result. In is equal to 1 minus 1 upon 2n times of in minus 1 minus 1 upon n into 2 to the power n plus 1. This is our first result, which we have to prove. Now, putting n is equal to 2 in equation number 2, we have I2 is equal to 1 minus 1 upon 2 into 2, and I2 minus 1 minus 1 upon 2 to the power 2n, 2 to the power 2 plus 1, which gives us 1 minus 1 by 4 into I1 minus 1 upon 2 to the power, this is 2 to the power 3 and 2 to the power 1, 2 to the power 4. 1 minus 1 by 4 is nothing but 3 by 4 into I1 minus 1 upon 2 to the 4 means it is 16. So which gives us minus 1 upon 16. Let us give it equation number 3. Now we want to find out the value of I1. How to get the value of I1? So we just put n equal to 1 in the equation number 2. I1 is equal to 1 minus 1 upon 2 into 1. I1 minus 1 minus 1 upon 1 into 2 to the power 1 plus 1. 1 minus, this is 1 minus 2. 1 minus 1 upon 2. I0 minus 1 upon, this is 1 and 2 to the power 2. If we simplify it, 1 minus 1 by 2 is 1 by 2. I0 minus 1 by 4. Give it equation number 4. Now we want to find out what is the value of I0. So if you put n equal to 0 in the first equation, we have I0 is equal to 0 to pi by 4 sine to the power 0x dx. So anything has power 0 is 1. So sine to the power 0x is 1. If we integrate it, integration of 1 is x under the limit 0 to pi by 4. Therefore, the value of I0 is equal to pi by 4. Now we substitute the value of I0 in equation number 4, then we have the value of I1. We have the value of I1, which is 1 upon 2 I0 minus 1 by 4. 1 upon 2 into I0 is 5 by 4 minus 1 by 4, which gives us pi by 8 minus 1 by 4. Now we substitute the value of I1 in equation number 3. We have equation number 3 is I2 equal to 3 by 4 I1 minus 1 upon 16. The value of I1 is pi by 8 minus 1 upon 4. 3 by 4 into pi by 8 minus 1 upon 4 minus 1 by 16. If we simplify it, 3 pi upon 32 minus 3 upon 16 minus 1 upon 16. Again, if we simplify this part, it is 4 upon 16. 4 upon 16 means 1 upon 4. Then the final answer is the value of I2. The value of I2 is equal to 3 pi upon 32 minus 1 by 4. This is the final answer. Thank you.